Interface is an object which will give us abstraction in our architecture. Where we can use interface? What if we have functions with the same name? And do we have case where we need to connect them with multiple structures for totally different implementations? In that case, we need to create abstract things so we can manage that kind of architecture. For this kind of problems, we will use interfaces. We have two groups of interfaces. First group is interface with list of methods, and second group is empty interface. In first group, we said that interface will have a list of methods. What is the method? Methods are abstract functions, which means that they can have more than one implementation. So let's see how pattern for this kind of interface works. First, we will type reserved word type, then we will declare interface name, and after that we will declare a reserved word interface, so we can recognize that this object will be interface. Next, inside of our block, we will write our methods. How we write one specific method? First, we will type method name, then we will put list of inputs, and then we will declare also list of outputs. What is the difference between method and normal function? Well, method has own pattern which can be used for many different implementations, and it can be connected to many different structures, also with the same name. So let's see one real example. In this case, we have animal interface with one method. This method will expect from us one variable as data type string, and we will expect from this method two variables where both variable will be integer 32. The question is, where is abstraction in this writing? This interface animal can be connected, for example, with three different structures: lion, wolf, and bear. This method population, in this case, can have three different implementations. In this case, first implementation is connected to structure lion, and in a real example, we want from function to give us number for male and female population for lion in specific country. Also, we can connect this population with structure wolf, but in this example, we will also have the same pattern as the first one. What is the difference? For the first input variable as data type string, we will have alias forest, and output will be also two different numbers as data type integer 32. We will expecting two different numbers where we want from our function to give us number of female and male population for a wolf structure in one specific forest. As we can see, we have one function with the same name but connected with two different structures. Also, the pattern for input list is the same because in both functions we are expecting one variable as data type string for our input, and we also expecting two different variables for output as data type integer 32. They are also connected with two different structures, but they have totally different implementations. In final picture, we accomplished our abstraction. Let's now see how we operate with empty interface. Empty interface is an object which can have any data type. We have abstraction above all data types. Where can we use that kind of object? Let's say we have a new structure user. We can set that this ID has data type empty interface. The real question is, what is the final data type of that attribute? That's the trick, because that empty interface can be whatever we need at specific time. For example, in this case, ID of user can be string, but also in some other cases can be integer 64. Final picture of that user structure will be that our ID doesn't have final data type. he is not only expecting string data type, he is expecting string or integer 64 data type. We can pass both data types from any variables to that attribute ID. Let's now see how empty interface works in function. We have function sendMessage, which is connected to our user structure, and we have one variable as input and one variable as output. In this case, our function is expecting from us one variable, but that variable doesn't have final data type, which means that we can pass string or integer or boolean or whatever we need to pass at that point to our function, and function will receive in any case our variable. On the other hand, after implementation, function doesn't know yet what will send to us as output variable. We have also empty interface as output variable, which means that we are expecting one variable from our function of any data type. In our return declaration will be one variable, and we can pass value of any variable with any data type. That's how we can achieve 0 point of abstraction, because in any case we don't have final data types. Now we will enter inside of our environment and we will write real code so we can see how real examples of interfaces works in our architecture.